So when you need to be able to provide the names and essential details for each layer of the internet and OSI models, this is the internet model and this is the OSI model. In the slides, and this is something I thought I would call out, it's the International Standard Organization that created the OSI 7-layer reference model. That's the acronym for the organization that created the OSI 7-layer reference model. These 7 layers are commonly referred to as OSI, which gets confusing when you see ISO, right? So ISO is the organization, standards organization that created the OSI 7-layer reference model, and I just wanted to call that out. So just understand, if we're talking OSI or you see ISO, that's 7-layer. If we're talking internet, we're talking 5 layers, right? This one is the standards-based organization with scientists and engineers. This one is the tech industry, right? That's another distinction between those two. I do want you to understand, I do want you to be able to label these. So it would probably, for your assessment coming up, and yes, what else did I revise? You need to have your solution done by the start of class Monday. And it's not going to take long. We'll walk through that in just a minute. In fact, we're going to walk through each of these learning objectives to make sure we've covered everything. I do want to talk about synchronous and asynchronous communication because we've talked about a lot of these other terms, but not synchronous and asynchronous. I just wanted to provide some definition there. So by Monday, the solution is due. By 3 Wednesday, the assessment is due, start of class. By next Friday, the reconciliation, and then by the following Monday, you need to have the second attempt for the retake taken, okay? So, yeah, perhaps an easier view of our, well, let's finish our thought here. So the OSI model, reference model, it's about protocol stacks. It has 7 layers. I want you to notice the common things. So I'm gonna give you an easy button. When you're trying to remember for the assessment and for your midterm exam, okay, which layers are what? Remember the top 2 in either case are application. The bottom one in either case is physical. Okay. When you hear about the network interface layer, that's the industry model, the internet reference model. And people often refer to NICs. So the trick here is not to get confused with the term network over here. Okay? So what am I saying? You can get tricked by thinking this is the network layer. No, in the internet reference model that the tech industry uses, this is the network interface layer. This is what's called the data link layer on the OSI model, okay? It's an interface is where the physical links to the data. Let me say that again. An interface, a network interface, is where the physical media links to the data, right? Which is why we have this separate label here, data link, right? It had to be different. The internet layer is the same as the network layer over here. Remember that if you're seeing the word internet for layer 3, we're talking about the internet reference model. And that's the one that industry uses, Cisco uses, Microsoft use, right? 3Com, all these different wireless companies, Netgear, D-Link, all these popular names that you can find when you go into Office Max and you look at all these network wireless adapters and such, right? TP-Link, this is the one that the industry uses. The transport layer number 4 and transport layer number 5 are identical. So that's another cool thing that's similar. The top layer is the same, the bottom layer is the same, and the transport layers 4 are the same in both cases. We form a session after transport layer is cleared. We form a session where the data is presented to the application. Let me repeat that again. On the OSI reference model, when the transport layer has completed its work, there is a session formed that presents, that's in the presentation layer, the data up to the application. That's one way that I try to remember the order, right? Okay, so it's session, presentation, application. Try to recall that sentence, and then I have it clear. Okay, are there, now what else do you need to know on this level? That there are chunks of data that are encapsulated and embedded, and as you move down the layers, the chunk of data gets bigger and bigger and bigger because we're adding more and more headers. And then when you move up the layers on the other end, the chunk of data gets smaller and smaller and smaller because you're unpacking. So the whole idea of encapsulation, the whole idea that there's a header at each level and there's this packing list we call a CRC, those are things that are common to both of the models. Any questions about our comparison between those two models?
No questions.
Yeah. Now, the people in industry that are working the network side, they don't like getting into the computer science side of things. They're like, oh, creating a session and presenting the data of the application, that's all coding stuff, man. Just flop it all into an application layer. We don't want to deal with that bupkis, right? We don't want to deal with that. So that's kind of why they do that. The industry partners that do networking, that provide the equipment, are really not software oriented, which is a shame because they would do their job better if they were. I'm just saying. And yes, I have 20 years in industry, so I'll just have to apologize for my colleagues in that regard. Just remember the differences that can trip you up here, right? The idea that this one's network interface, but over here, that's not the interface layer. It's where the interface links to the data. Oh, that's the data link layer, right? Okay. I'm going to go back up to our, now, do you have to know much about the 4-layer model? No. I used to emphasize this a whole lot more. The difference between research and development, that's the scientist and engineering part, and then the industry practitioners, the network companies, right? And they had different, like they had H to H transport, and this one was called, I don't expect you to know that. What I do want you to see here, and the reason I'm providing you with this graphic, I have these two side by side, and the original 4-layer model was the TCP/IP protocol that industry people used, and the application layer swallowed application presentation and session layers. You can see them side by side here. That's convenient. The other thing that I like about this graphic is that it shows you application layer protocols. Telnet is an application layer protocol. FTP, which is file transfer protocol. SMTP, simple mail transport protocol. DNS, domain name service. RIP, that's the routing internetworking protocol, right? SNMP is simple network management protocol. TCP and UDP are on layer 4, which is the transport layer. And in the original model from industry, well, they didn't have 5 layers. So they weren't in sync with the OSI model. So in the oldest of models promoted by industry, they were really stubborn and really behind the times. TCP and UDP were on this host-to-host transport layer, but then they just, when they updated, they said, oh, screw it, we're just going to drop the host-to-host stuff and put transport layer, okay? The most important thing I want you to understand is that the internet and this networking stuff started out in part because of DARPA. And in particular, when you click the links and then you go into these additional websites, what you'll find is that the French, and this is a point of honor and pride, you know, Dr. Boumediene, our department chair, and my boss is French. He's from France, and I think Paris. And he has, you know, his family in, the Marseille, I think. It's on the coast. Beautiful, beautiful area. Anyway, it's a bunch of French researchers that basically figured out how to establish the handshake and get a persistent session to take place. And they are the ones that did the primary legwork that led to the TCP methods that we use all the time. And we wouldn't have an internet without it. So for what it's worth, it really was an international development, but the origins that started were because our Department of Defense Advanced Research Project, right, agency, Department of Defense Advanced Research Project Agency said, oh my gosh, we got to do something, because if the Russians take out two different telephone centers, one in St. Louis and one in Denver, then the West Coast can't talk to the East Coast, and that's a problem. So anyway, I hope you remember that. I hope you remember that history. It's important history. Let's go back up to our, any questions so far? So when we talk about telecommunications, we're talking about telephone and telegraph and circuit-based networks or circuit switch networks. When we talk about digital communications, we're talking about ones and zeros flowing between the hardware components inside a system, and digital networking is in between systems, and it's data networking. It's not telecommunications. So this is a complete connection from start to finish. There's a single metal wire loop, and people can talk and hear each other in real time. That's synchronous communication. It means that you can send and receive at the same time. You can hear and talk at the same time on a telephone. A data network can also send and receive at the same time. So a data network can send and receive packets simultaneously. That's what synchronous means. Asynchronous means, okay, I'm downloading, now I'm uploading. It's, there's gaps between the downloads and the uploads. That's what asynchronous, A means no, like sexual reproduction in biology. Asexual reproduction is, no, I'm not doing sex to reproduce. It's when cells divide and stuff. Everybody know what I'm talking about? Kind of, sort of? You've had biology? No? Yes? Maybe?
Sort of.
Okay.
Kind of.
You know that plants can asexually reproduce, right? They don't have to have sex to reproduce. But plants also do reproduce through a method that involves two different gametes, right? Their pollen is the sperm of a plant. I'm not going to get into this very far, but I just wanted you to know what that A means. Whenever you say typical and then you see atypical, it means that's normal. Typical, atypical is not typical, not normal, and in terms of English. So we all know what a stack is. It's when you have these layers of protocols that are interrelated that pass traffic back and forth. LAN is local area network. It is also the same as an intranet. That's a network within an organization, and it may involve more than one LAN. So you can have an intranet that's quite extensive, but if you have a network within an organization that is not shared with the public internet, that's called an intranet. inside the organization, intra. That's the same as intracellular transport. It's like biology. I'm using those biology terms again. Internet, so that's between networks. It's a network of networks. So everybody else has it, right? What the interface is a link to the data from the physical layer, right? What we just said. Okay. We've talked previously about circuit switched and packet switched. We've talked about the 5 key aspects of networking. So you have signals over wires, you have bits over signals, and then you have frames over bits, packets over frames, right? Everybody know what I'm talking about there? Kind of, sort of, maybe?
Yeah.
5 aspects of networking, which kind of tracks with the layers. So if you get stuck, just remember to think of the layers. You have the physical layer first, and the first key aspect is the physical, wires, signals over wires. That's how you connect those two. We talked and discussed on Wednesday the 2 components that are embedded in a network address and how the subnet mask helps to discern those, right? You're given in a single network address, what's embedded in there is the network identity that device belongs to and the host address, right? So we want you to be able to, when I say draw a line, I could have said, or use highlights, you know, or determine, right? You can do it graphically, you can draw, you can whatever, all right? We've talked about public and private networks, how there's number ranges that are designated for the public internet, and there are special numbered network ranges that are private. And we want you to be able to identify the IP address ranges by classes. We didn't talk much about APIPA. So I want to zoom down in the study guide to review APIPA. That stands for Automatic Private Internet Protocol Addressing. And basically, here's the next one that's associated with that. Given the scenario, choose the most suited private IP address range. So that learning objective is tied to your knowledge of the private networks. Let's take a quick look at what we mean by that. Okay. So these are the official public network, and I'm going to change that public, right? Those are the official public IP address ranges. And so if your first octet is anything from a 1 to a 126, that's a Class A address, which means it can support millions of connected clients and networks. Class A networks, there aren't very many of them, but each one of them can support millions of devices. The Class B networks are smaller, and there's more of them. And they start from the 128 to 191 range. The Class C networks, those are even smaller yet. These support up to 253 devices. These support 65,500 and 500 and change, 65,500 and change devices. So millions, 65,000, 253, and then this is even smaller yet. This is for research and experimentation. People don't generally configure these numbers. Let me repeat that. People don't generally configure these numbers. It's for research and experimentation. And when the aliens come down and you have to figure out how to plant a virus in their spaceship to save the world. Just wondering if anybody heard that.
For class A, 127 is not listed. Is that a loopback?
It is loopback, and I'm very glad who said that? I am so glad you said that.
Robert.
Robert, I got to post additional credit for you just for that. Thank you for bringing back 127. You saw the asterisk, right? And you notice the gap. It goes from 126. There's no 127. What most people, and let me do this here. All right, so what is loopback? Most people, there's a joke, right? There's a T-shirt that says, "There's no place like." Has anyone ever seen The Wizard of Oz? The movie The Wizard of Oz?
Yes.
Okay, and so Dorothy at the end of the movie goes, "There's no place like home. There's no place like home. There's no place like home," and she clicks her heels. And there's a T-shirt that says, "There's no place like 127.0.0.1." So what are we saying? If I want to test, I can ping myself. I can ping home. I think home doesn't work here because that's a name, right? I think in Linux you can actually say ping home on some distributions of Linux, but if you want to ping yourself just to test to see if it's working, you use the home, the 127 address range. And there's an entire range to use. And generally, people always talk about 127.0.0.1. And if you ping that, then basically you can talk to yourself, even if there's a firewall. And that helps you to troubleshoot which aspect of your networking might be broken. And that address range is special and unique. And you could say it's private, but more to the point, that's for your loopback. The other name for this is loopback. When you ping 127.0.0.1, the packets go out and they loop back and they return a result, which is why Robert used the term loopback. It's a techie term. So the T-shirt says, "Hey, there's no place like 127.0.0.1." And if there are network guys and gals in the audience, they see that T-shirt, they're like, and they know, and they also happen to know of the phrase, "Hey, there's no place like home. There's no place like home," which actually was a line from Wizard of Oz. And it's probably in other movies too, and in other songs. There's no place like home. And that's true. Anyway, there you have it. Thank you for helping us cover that base. So here you see the private address ranges. If you see anything with a 10, it's private. It can have up to 16 million different computers. We mentioned the US Army has a single domain and millions of devices. Massive US Army. There's a 20-bit block range, 172.16 through 172.31 is the Class B range. It can support up to 1 million addresses. And the 16-bit block range for private addresses is 192.168.0.0 through 192.168.255.255. So by the time you finish filling out this octet with a 0 on the end and then put a 1 on the end, run through those numbers again, put a 2 on the end, run through those numbers again, 0 through 255, run through those numbers again. You have 65,536 addresses, one of which has to be the network identity. The first one has to be network identity. Another IP address is reserved for the gateway, and a third one is called broadcast. We're going to get into that next module. We're not talking about broadcast right now. The important point I want you to know is that if I give you a scenario and I say, hey, you have an organization and they need, they have 30,000 addresses and you don't want to allocate more private network than you have to, which private address range is best? This is the Class A private IP address range, the Class B private address range, and the Class C private address range. Now, why did I use the letters class A, class B, class C? Because 10 falls within this range. 172 falls within this range. It is technically a class B address. And then 192 starts here. So I may ask you how many. The other thing that's important to understand is that it, your author of the book calls out this first octet higher order bits. What we mean by that is a 32-bit network address is ones and zeros. If the very first value is a 0, that's a big network. It's huge. And on a binary level, computers can figure out, wow, okay, we're routing this out to the internet, and it's one of those big networks. Happens very fast. Look at the progression and the pattern, right? If it's a 1-0, that's a class B. If it's a 1-1-0, that's a class C. And if it's a 1-1-0, 1-1-1-0, it's a class D, which again, we never use, except for top secret stuff. Okay. Any questions on how we determine the breakout of the private addresses? Now let's talk about a Pipa, automatic private IP addressing. That's what that stands for, a Pipa, automatic private IP addressing. Sometimes you don't have the automatic assignment of addresses that are active on a network. You don't have DHCP running, and we're going to talk a lot about that in the next module so that you become experts in all things DHCP. Woohoo! You're going to be able to slice and dice networks and set them up in your sleep. It's going to be really cool. And you're going to use Packet Tracer for that. So, to me, that's where all the fun begins. But the important point is that you know that IP addresses are automatically assigned normally using this protocol called DHCP because you don't want any two network addresses on the same network to have the same network address. Otherwise, things go boom. Right? They also want you to know that when you have local internal networks, they encourage you to use the private IP address range. Do not use public IP address ranges, even if you own them, because the private IP address ranges are non-routable, which means that if somebody gets into your goodies in your Kool-Aid, they can't route that data out plainly. If it's a public network address and they get into your Kool-Aid and your data, and you're sitting out on the internet with a public address, if they get a hold of your data, they can easily route. They can route your data much more easily. So these are non-routable address ranges. We'll find out what that means in Module 3. So when we start talking about internetworking, when you have two network devices and your DHCP isn't working, your devices are normally set to automatic. Your laptop's set to automatic. Your TV is set to automatic. What happens if there's no DHCP server? Your devices automatically pick up a 169.254 address with something that's unique in these last two octets. It uses a /16 subnet mask. And that means that anything in your network, any other thing in your network, right, basically automatically assigns something random. And because this address space is so huge and it's randomly assigned, the odds of a collision, and the odds of a address collision are very, very slim. Let me repeat that. Because this additional client address range is so large, and they're randomly assigned across the entire range, it's very unlikely that the two or more network devices would end up with the same network address, and then you'd have a crash. So when you don't have automatic address service, so why do they do that? Sometimes devices like to work in a network environment from peer-to-peer, meaning, well, you have a network, you have a wireless in your house, it's not working right, but you still want to be able to do stuff between wireless devices. So that's the reason why they formally use this special address assignment. So 169, the reason it's not called out here and you don't see a gap here is because it's followed by a 254. That's a very narrow range. The second octet is 254. So most of the 169 range is usable as long as the second octet is not 254. So if it's 169.253 or 169.255, anything other than 254, it's public and it's up here, and it's a Class B range, which can support many addresses. Any questions about this? Okay, so let's talk about, all right, we said if you're given a scenario, you have to choose the most suited private IP address range. You would not choose a Class A address if somebody needed 30,000 addresses. You wouldn't want to set up a Class A network for 16 million computers, potentially. That would give hackers all the room in the world to do whatever they wanted. You would want to use a Class C address. So does everybody understand what I'm talking about here? If I give you a scenario and ask you which class of network would you want to set up? You have been hired as a network professional in an organization, and they have 500,000 networked devices. Which class of network are you going to use? Class A, Class B, or Class C? Let's see if you were paying attention to what we were just showing on the screen. Well, the Class A is 16 million. How many in a Class B? I'm also talking about a private network too, by the way. I'm not talking about a public network. Would you want to use the one that's rigged for 16 million or 1 million or 65,000? Which one would accommodate 500,000 devices?
That's it.
It is true that the Class A would accommodate 500,000 addresses. But is it efficient?
No,
Yeah,
because it would leave a lot of addresses unused.
Yeah, it's kind of wasteful. You want room for growth. So if you have 500,000 and you pick a Class B address range, you can support up to 1 million addresses. So that's better. If I said, oh, you have 10,000 addresses, which one are you going to use? Class C, right? Because you don't want to be wasteful. You have plenty of room for growth, but you don't need one that has 1 million or 16 million addresses. I hope that makes sense. Okay, so let's talk about what you got to do for your solution. Packet tracer. You're going to install Packet Tracer. Once you install Packet Tracer, when you open Packet Tracer, it's going to ask you to log in to your Net Academy. That's what it's going to do. It may prompt you like this. It may say, oh, wait a minute, Defender Firewall has blocked some of these features. You're going to say, okay, check both boxes, allow access. We'll talk about that later. Use your Cisco Net Academy login. So I'm going to type this in. And I'm going to click next. And eventually it's not going to show me anything except unless I put in my password. I hope it still works. That's a good sign. Now, you're going to pull your packet tracer down. In the lower right corner, you have this really slim button, so you can minimize everything. You're going to have your packet tracer open like this, and it's not going to be maximized on the screen. It's going to be resized. This is called the resize button. So you're going to do like this, and then you're going to click on your start menu so that I can, and hold your pointer over this so I can see your login. With Packet Tracer open in the background, I want to see, when you click on the start menu, hold your mouse over the user, probably be your name and not owner, right? Press the print screen button and paste it in. That's what I want you to paste in for your solution. There are 3 points for this. And if you don't meet all the criteria, if I can't see your name, if this isn't open and running, you know, if you show me that you Cisco Packet Tracer here, but it's not open, then I don't know if it's properly installed because you got to log in to have it open, right? So the idea is to show that you've properly set it up. Is anyone having any difficulty navigating the lessons and the resources online in Cisco to learn how to install it? Would anyone like me to show you how to do that now without having to walk through?
Quick question.
Mm-hmm.
I have an older version of Packet Tracer I used in high school. Would that still work?
Can you log in?
Yeah.
But it's a different login, right?
Well, it's similar to what you have here, of what you have this set up here as your Packet Tracer, but some of the routers and stuff look different.
Mm.
So the image for the routers look different. It's a very older version I used in high school.
Yeah, I would rather you have the new version.
Okay.
I understand and appreciate the investment there, but if I put stuff into Net Academy for a class and you're using your old Cisco Packet Tracer and there are different looks and different views, the videos that I record for the solutions that follow in modules 2 through 6, your screens are going to be different, the stuff on there is going to be different, and that's going to throw you off. Does that make sense?
Yeah.
Okay. All right. So I want you to do 2 other things to identify layer 2 through layer 4 detail on your system. The first one is to open a browser and go to, I've showed you GRC Shields Up, yes? Haven't I done that before? Have I not shown you GRC Shields Up?
Kind of remember something, but not sure.
So it's the vulnerability profile
Oh, yeah.
scanner. You click proceed, and then there's a silver button in the middle. So you're going to do this, and it's going to run this. Now, this IP address is layer 3. So that detail is layer 3. The TCP and UDP stuff that you're seeing here, graphically represented, that's layer 4. So the port numbers are TCP and UDP oriented, and that's a layer 4 specific. Does everybody understand what I'm saying? Well, just remember that port numbers have to do with TCP and UDP on transport layer. And we'll get into that more when we get into module 2. Once you get a complete screenshot, or even before that point, you can just screenshot this. So the first screenshot is Packet Tracer open, showing the account. The second screenshot is this one showing your IP address and some ports on layer 4. The last thing you're going to include is either of these two commands. If you want to do both, I'll add extra credit. You type in CMD if you don't have command prompt here. And when it shows, you're going to right-click and run as administrator. You'll answer yes. If you don't have an administrative login on your system, try it without administrative. But you're going to type in ipconfig. And one of the things that you'll notice is that if you just type in ipconfig, it doesn't show you the MAC address, the media access control, on the data link layer, on layer 2. It doesn't show you that. It shows you the IP address, that's layer 3. And this is IPv6, IP version 6 address. It's actually 128 bits long. So we're not even going to worry about that right now. But the way that you make ipconfig, on a Mac, you're using ifconfig in the terminal prompt. What you're going to do here, though, is you're going to add a space, / and the word all. When you do this, it gives you the MAC address, the physical address, right, which is on the data link layer. So the MAC address or physical address that links to the data on the data link layer, it's this 48-bit hexadecimal value, and you're going to highlight it like I'm doing on your wireless or your Ethernet, whichever one you're using to connect. And that's the final screenshot. You're going to capture this screenshot. That's layer 2. This is layer 3. Now you're saying, wait a minute, this doesn't match this. Well, that's because, and we're going to talk about this next module, this is your local internal address. Your wireless router translates this into a public address once you go out to the internet. So you're getting layer 3 details, but this is public IP. This is the private IP in your house. Does everybody understand the difference? And we'll get into, we'll get into the translation process and why we do that next module. Okay. Now, what about the Netstat? We talk about that at the end of your, or netsh, right? So you can use other commands like netstat and netsh, and I would encourage you to do this. Now, the output can be pretty big, but for extra credit, you can do netstat-a, and you can redirect it to a temporary file, okay? And then just upload the file, and I can look at it. You can also do netsh. This command in particular is really useful. Netsh interface IPv4 show neighbors. That shows all the neighbors that are connected. So I'm going to use that right now. I'm going to right-click and copy that. I'm going to go into my command prompt. I'm going to clear the screen just so you can get a screen clear here. Everybody with me still? I'm going to
Yes.
Yes.
I have a question after class.
I will press my right mouse button, and the moment I do, it's going to repeat what I just copied off of that Word doc, but I have to hit enter. And this shows the network, this shows the neighbors that are sitting out on my network. Now I have some virtual machines with virtual interfaces, so you're going to see some weirdness here. But this shows the neighbors that are sitting out there on your network based on the network interface, right? So I have the loopback have the loopback interface, that 127.0.0.1. I could use 127.0.0.2 or 127.0.0.3. I have the whole 127 range to use for loopback. People just use 127.0.0.1. Anyway, I'm going to look at my interface for the wireless. And when I get down to that, you get to see that, yeah, I have some interesting things on the screen. All of this is hard to show in one screenshot, so the best way to do this is to have the command, put a space in there on a redirect character or function, right? And I'm going to redirect this to C:\temp, and I'll call this backslash, I'll call this netstat underscore example.txt, right? So I do that, and it takes all the output that you saw on screen and puts it in a text file. If I go into my C drive temp folder and I sort for the date modified, you'll see it'll float to the top. If I click date modified, that it was just created, so it's going to be at the very top of the list. And you'll see in here that it's 4 kilobytes large. It's always good to redirect network analysis or network commands, network utilities to a text file, because then you have a permanent record. The next one I do is netstat example 1, example 2, example 3, and then, you know, I have different date timestamps. I know when I ran the command. It's a very convenient way to keep track of network analysis and troubleshooting details in a convenient manner. Does everybody understand what I'm talking about here? Or does anybody have any questions about what I've just showed you? I just showed you this one netsh command. Let's try the netstat command. So I'll go ahead and enter this one. Netstat -a redirect to cnetstat result 1. Yeah, I'm going to change this slightly. So I'll copy it. I'll clear my screen. I'll paste it with the right mouse click, but I'm going to use my left arrow key, and I'm going to put temp backslash, so I put it in the temp folder. That one's going to take a little longer because Netstat generates quite a bit of stuff, and it runs through all of the port ranges. It does something more comprehensive, similar to this. It runs a whole set of ports, in some cases all 65,000. These are the common ports, 0 through 1055, but you actually have like 65,000 ports on layer 4 to work with, in addition to all those IP addresses. So that's kind of useful. Once again, the netstat and netsh commands are optional. It's for additional credit. When I post the assignment document for the solution later today, you'll see that detail in the additional credit section, okay? Any questions about what you're doing for your first solution?
No questions.
Okay. Well, I am gonna finish just tweaking a couple of things with this last study guide. Most of the detail in the previous study guide is still valid, but I just wanted you to be aware. I'll send it in email also, so you have a latest copy, revision 1A. What's out on the Blackboard website right now is revision 1 in the reference folder. And you'll see 1A out here in a few minutes, okay? Unless there are other questions, I was going to go ahead and conclude the lesson today. I hope you all have a good weekend. And I'm available tomorrow. If anyone has any problems with your solution and you'd like a hand, just send me an email or text me. I can share a
Hey,
screen
Professor Kenta,
and walk through it, okay?
have you seen what's been happening with the GameStop, the GameStop stock situation?
Hang on a sec. So, yeah, all right. So what were you saying about the GameStop?
So apparently, like the main apps that people use, they ban you from buying the stock now. You can't even buy it anymore.
Right. Well, they don't want this. They don't want the market to be manipulated. If this starts to happen to more companies, it can create an imbalance in the economy. That's a simple way of putting it. So the fact that they're restricting that trading right now, they're trying to stop something from getting out of hand where it can be manipulated. A lot of times if you artificially inflate and then cash out, everybody else that tried to get in on it has put money into it, and then when they try to cash out, oh, too late, 10,000 other people have already sold their stock, which means that everybody who has shares left is out of luck. So it's a great way to steal money from people if you're intentionally manipulating the market and the market pricing. Does that make sense?
Yeah, but even Tesla down today. Tesla back down to 792.
Oh yeah?
Yeah, but my main problem is my friend bought some cheap stock yesterday, like AMC,
Uh-huh.
and they straight gave it back to him. Like they refunded his money and took away his stock. That's my main problem.
Well,
Like you don't even want you to have the stock anymore.
because now the same crowd is trying to do the same thing with AMC. And it's a market manipulation. So people get excited, they put all their money in that stock. The folks who started the rush are waiting for the price to go up, then they cash out quickly and sell their stock, which has gone up several times in price. They make a ton of money, but then the price crashes, and then everybody else who put all that money in there is trying to get their money back out, but they can't, and they're bankrupt. So it's a sophisticated way of transferring wealth that's illegal and it's unethical, right? If it's intentional, and if it's massively intentional, if it's a manipulation, it's illegal. Okay? But sometimes prices go up and down naturally without intentional manipulation. And yes, a lot of people do make money that way. So I
All
appreciate
right.
the update on it.
Just
I know
one
you
of my friend was just a big fan of AMC. I just wanted to own stock. Like,
right,
come on, man.
right. Yeah, he ought to be able to. One way you might be able to do that is to invest in a mutual fund that also buys stock in companies like AMC, and they probably have AMC in the portfolio.
Yeah.
Yeah, it's an indirect way to own it. Yeah, you could research if any mutual funds have, or stock portfolios include AMC.
Or find a ETF that deals with theaters.
Yeah, I mean, there's all sorts of possibilities. It's an exciting time, and what we have to be careful of is how shaping behavior on social networks can boomerang, right? So that's the human network manipulating the digital network to create crashes on the financial network. And that's how we'll conclude this session on networks. Have a good day.